Hello everyone, welcome back. Today we will talk about gradient descent. So you might ask yourself, what is the gradient descent? And you hear a lot about gradient descent in deep learning or CNN. Yeah. So assume that you have a model and you would like to update your parameters. And let's say, for example, in linear regression or in deep learning. So one of the most effective algorithm is gradient descent. So if you are not familiar with gradient descent, linear regression, how it's working, I made two videos, clearly videos. You explain every single step in linear regression with one example, and also it's used with gradient descent. So you can have a look and come back to this example. So gradient descent is a generic optimization algorithm that is used to find the optimal solution for your application. So we assume that we use linear regression. So the idea of the gradient descent is to tweak these parameters iteratively in order to minimize this cost. So how is it working? Let's say we assume this is the gradient linear regression. We assume that we have this data set here, just a small data set, and here's x1, try to predict y. Now theta 0 and theta 1, this is the formula or the equation of linear regression. So draw a line, this is the formula. Theta 0 plus theta 1 multiply x. And x here is each example. For instance, by the way, theta 0 and theta 1, it's randomly initialized in the first iteration. And you will compute next, you will compute the cost and try to minimize or update these parameters. And with updating these parameters, your cost will be also minimized. Now, if you have multiple variable, for example, x1, x2, x3, x4, x10, and y, and this, or for example, x1 to x10, try to predict the y column. So all of these parameters theta will be initialized randomly and compute the cost. Here's mean square error, and here's, for example, the y hat minus y. Let's see, we assume that we already predict y hat. For example, for this row, y hat is 7. Then 7 minus 6 will be 1. The square is also 1. And we will do it for the whole data set. For example, for this one, this one, this one, until getting the mean average of the cost. Now this is how it's work. Just multiply this and find the cost. And you have to compute the cost and go back to update the parameters. If your cost is high, you have to update the parameters. Now, this is the formula how to update the parameters. For example, here we have theta 0 and theta 1. Theta 0, here's the old theta 0, the old one. In the first step, in the first iteration, we initialize it randomly. And this minus alpha. Alpha, it's the rating, learning rate. And this is the derivative, partial derivative of the cost respect with theta. So I also made a video in this how to find the derivative, partial derivative. Now this is for the theta 0 and here for the theta 1. The difference between theta 0 and theta 1 is this one, x. So what's that? For example, for instance, let's assume we have to update theta 1. Theta 1, it will be the predicted y for example for this column minus y this one, and multiply x with this x5 in this case. And here it will be also the same, but because it's also multiplied by 1, x0. So in this case we didn't add it. So the general equation for this it will be theta j equal theta j minus this term and his x I theta ij. I hope you understand. If you are not, I made the video with example, you can see it. So now there are three types of or three algorithms with gradient descent: batch gradient descent, stochastic gradient descent, and mini batch. So what's the difference between these algorithms? So in batch gradient descent, it used the whole data set to update the parameters. So assume that this is your data, right? And you compute the cost for all row, and you compute also the average of the cost. And in batch, you have to compute the whole cost. I mean the cost for each row to be able to update the parameters. As you can see, assume that here's the alpha is 0.1. Just pseudocode. You can convert it to any language, for example, Python or R. And here's the iteration number of iterations. And in theta, because we have only two, in our example, we have only two. We initialize this theta 0 and theta 1 randomly, and this is the iteration from 1 to 1000. And this is for example the gradient. It's this form, this part of the equation, and you update now the theta. And it's in this example it's vectorized. It's not C++ code, or it's vectorized. It means, for example, here x transpose is the whole x, the whole data set, and here's x also the whole data set. Theta is theta 0 and theta 1. Y, the whole y. So you have to be clear about this one. It's vectorized. And here's the theta 0 and theta 1. As we said, it's randomly initialized. Yeah. So one question: how many updates? For example, if you have theta 0 and theta 1, just as example, how many updates will be? How many times you will update theta 0 and theta 1? So, as you see here, we have 1000 iteration. It means I will update it 1000 iteration. Each of the parameters will be updated 1000 times. Theta 0 will be updated 1000, and also theta 1 will be updated 1000 times. This is the gradient descent, but it has a disadvantage. The disadvantage of the batch algorithm is you have to wait until finishing the whole data set to compute the whole cost of your data set. It's super slow, and you have to find another example or another method how to do it with small data. The stochastic gradient descent, as we said, because the batch gradient descent is slow, the stochastic gradient descent it's super fast. Why it's super fast? Because we update the parameters only on one single example. For example, for instance, we have 1000 iteration, and we have m. This is number of datasets, number of examples in our dataset. And now, as you see, from 1 to iterations, from 1 to 1000, and from 1 to m, select randomly one row, xj, xiyj, I mean just only one row, x and y. Compute the gradient, update the parameters here. We update the parameter for only single example. Go back to this 4. Select the new one, the new random row, and you can do it. Update the parameters, and also for, I mean, till 100. So till this one, we update the parameters 100 times for only one iteration, right? So, and now for 1 to 1000, you have to update also again another meaning. So our algorithm here, it's update. I mean, each parameters is updated 10,000 times. So you have to calculate this. It's easy to find. Yeah, and by the way, for example, this is random. Stochastic gradient descent, it's random. So if you would like to make it for each for example, you can just do it here. For example, from 1 to m, and you can remove this random and select every single column or row in your data. And now the third mini batch algorithm, it's a hybrid between the batch and stochastic. So for instance, you have, for example, we have our data set has 100 rows. Okay, and the basic idea is to divide this 100 into 5 groups. So it means we have in each group we have 20 rows. Now for each batch we update the parameters. And for example here from 1 to batch size, for example from 1 to 5. In the first one we take the first part, the first split, compute update the parameters, and for the next batch, for the next split also we update the parameters. And you can see how many updates we have here. 5,000, because we have 5, I mean 100 iteration, and we have 5 groups, so it's 5,000. So if we go back to the batch, in our batch we have the number of updates is 1,000 times. In the stochastic it's 10,000, and here is 5,000. I think if you would like to use the gradient descent, you should use mini batch. This is also used by many researchers. That's it. So if you have any question, just drop in a comment. I will of course reply on this. Thanks. Have a nice day.